Hey y'all, welcome back to Shooting News Weekly. Today, we're gonna cover a topic that I love because it's so nerdy. This is the Earth, and we're going to talk about Coriolis Effect, which happens because, yes, the Earth is round and it is rotating towards the east. Now, if you're on the equator, you're going 1,040 miles per hour. Let's say 1,000 miles per hour. It takes you 24 hours, right, to transit, rotate all the way around, because that's how long our days are. That's how long it takes the Earth to spin. 24,000 miles around, 24 hours, 1,000 miles per hour. Now, if you imagine that you're 10 feet away from the North Pole, it takes you 24 hours to just go around that 20-foot diameter circle. So you're not going very fast, right? You're down here, you're going really fast. You're up here, you're going slow. You're halfway between the equator and the North Pole at 45 degrees, is that right? 45 degrees north. You're going at 700 something miles per hour, which means if you're shooting north or you're shooting south, your bullet suffers what we call the Coriolis effect, and that causes you to miss. Basically, it's because you and your target are going different speeds. I'm going to draw something here. Pardon me for my drawing skills, but the easiest way to explain what happens when you and your target are going different speeds is, I think, let's say we're looking down from above on a field, and we've got a hay bale out in the field. That's a stationary target. And then down here somewhere, there's a highway, okay? And we're in our car in the highway, and despite local laws and regulations, we're going 60 miles per hour in this direction. That's our wind. We're very fast. We're following the speed limit even though we're about to fire guns out of our car. 60 miles per hour in this direction. And right as we get perfectly perpendicular with that stationary target, we fire our rifle. What's going to happen is that bullet's going to kind of go like that, right? Because it's still going 60. So we miss to the right of the target. And that's shooting north, let's say, if you're in the northern hemisphere. What's really weird is if you're shooting south, you also miss to the right of your target. Because let's say we're here. We're at the hay bale, we've got our rifle, and right as the car is lined up with us, we fire. Our bullet's going straight, but the car moves. So we miss to the right of the car. We miss behind it. Just like if you're shooting south or you're shooting north in the northern hemisphere, you miss to the right because of the Coriolis effect. So obviously, y'all, this is an extreme example where one thing is moving and one thing is stationary, but it's the difference in speed that matters. And that is what happens when you're shooting 1,000 yards or more north or south. You or your target, one is going faster or slower than the other. And maybe that's your target is going 800 miles an hour and you're going 799.99. It's not a big difference. It's a tiny difference, but it's enough that you get that little bit of Coriolis effect on your bullet. At 1,500, 2,000 yards, it's 2 to 5 inches. It depends a little bit on how fast your bullet is. It's not a huge difference, but as you get farther and farther, it starts to matter a little bit more and more. And then it also matters if you're shooting east or shooting west. Again, you're on this ball that we call the Earth, and it is rotating towards the east. So if you're shooting due east, your target is going down away from you and you hit high because your bullet's going, the target goes down and you hit high. Now, if you're shooting west, your target is kind of coming up towards you and your bullet goes out, the target's coming up and you hit low. That's it, y'all. That's the Coriolis effect. Most people do not have to worry about this, even if you're shooting, I say past 1,500 yards is where you might start to care about it a little because you're going to start being 2 inches to the right. In the southern hemisphere, by the way, if you're shooting north or south, you're going to miss left. It's the same thing as like pulling a drain on a big sink, right? And the reason we see it spin is because the south side is going a different speed as the north side. If we're shooting across the equator to a target the same distance from the equator as us, there's nothing. We're going the same speed. Really weird stuff. I geek out about it. People get confused because I think if you shoot north, you miss right, and you shoot south, you miss left, and that's not the case. It's right in both because of the car and the hay bale. Were you watching? That's it, y'all. If you have any questions, you want any other nerdy topics poorly explained, let us know in the comments below. Please subscribe, and we'll see you out here, hopefully with more shooting on Shooting News Weekly next time.